My countdown to get rolling. All right, ready. Here we go. Let's start right off. Parallel lines. Parallel lines. Something you did work with last year in Algebra 1. Absolutely. So before we turn it to where do we use it in geometry, let me ask you about the 2 facts that you learned last year about parallel lines. 2 facts you should have learned. Gracie, 1, never intersect. And another big one from algebra last year. If 2 lines are parallel, I know they don't intersect, but also same slopes. Remember those days. Same slopes, yes. Oh, how do I relate it to geometry now? Now we put these parallel lines on planes. So if you could, from yesterday, make your cube for me. That's garbage. Let's try this again. Okay, so now that we put it on a figure, parallel lines are coplanar, meaning they're on the same plane. How many planes are showing right now? 6. So I need you guys to give me a pair of lines that are on the same plane but do not intersect. All right, so that's what I'm going to ask from one of you guys right now. Give me a pair of lines on the same plane but do not intersect in each other. Let's start this off right. Hey, 15, let's start it off. AD and BC, I like it. AD and line BC are indeed parallel. Notice I left a little gap. I am not writing the word parallel. We do symbols in here. Anybody know the mathematical symbol for parallel? Parallel. Ooh. I don't do this either. We're not doing karate in here, all right? I'm not going to take this. Use our big boy, big girl words here. All right, let's try it out. 2 lines. All lines are straight. That drives me nuts. All lines are straight. That's not the parallel symbol, but that's what you told me. There we go. They're all straight. You don't need to. Thank you. 2 vertical lines. 1 does not make you great, honors kids. Give me another pair of parallel lines up here. Oh, 17. Let's rock and roll. What do you got? FE and DC. I like it. Good, good. 45 seconds, you and anybody around you. Numbers 1, 2, and 3. Do not write all segments. Just give me 1 segment. All right, that's parallel to each of them. Go ahead, about 45 seconds. All right, let's hear from you. What'd you get? Oh, by the way, I should mention this. We're going to go over this later on today. That new symbol there, okay? You know, it's not technically a line because it's not, you know, they don't draw it out forever, but they could. So instead what they did is they made it a line segment. I didn't want you guys to get freaked out. I'll go over it here in a couple minutes, okay? But what is parallel to AC up here? Parallel to AC. You're up 6. DF, you're good to go, DF. How about EF? What's parallel to EF up here? How you got 8? Where are you? EF. B. C. Nice job. And how about AD? What's parallel to AD up here? 17? CF. Nice job. All right. So parallel lines, any issues? Okay, now we have these other types of lines, which are called skew lines. All right, a little bit more difficult to see. If you read the definition in your packet there, you're going to be like, excuse, what? They're not parallel and they don't intersect. How about that? Think about that. They're not parallel. How is that possible? Everyone agree with me? How is that possible? Because it's got to be one or the other. They're parallel or they intersect. How can it not happen at the same time? Ready, kids? All right, think 3 dimensions here. 3 dimensions. Pick up your pen, Isaac. Put it along one of the edges right now of my cube. Hold it up there. There we go. All right, everyone see that one right there? Ready? Are they parallel? And we're in 3-dimensional here. Are they ever going to intersect? No. Everyone see what I'm talking about? These 2 pencils we have up here now are skew lines. Okay, skew lines. Skew lines? No, they're parallel. Okay? Skew? Why not? They're not going to intersect each other, right? Everyone see what I mean by skew lines now? They're not on the same plane, they will never intersect, and they're not parallel. All good? What was that? Come on. No. Oh my. Cube. It was cube. Come on, get on your A game here, honors kids. Not just know the math, know the slide effects too. So I need you right now, 45 seconds again with your partner, AC, EF, and AD. Name one segment that is skew to it. Skew. It's not on the same plane. It's not parallel to it, and it won't intersect it in 3-dimensional space. All right, here we go. We can play a little game. Where did I just put my pen? Anybody? Oh, there it is. Never mind. Got it. All right, here we go. AC, skew to AC. Let's roll. 11. E, B. I like it. How about skew to EF? What do you say, 22? EF and AC. I like it. Anybody have anything skew to AD? Oh, 8. AD and BC. Yep, those will never intersect. Not on the same plane. Nice job. All good. And again, those aren't the only ones. There's more that could be skewed to that segment, so don't erase. You're probably right. All right. Lines can be parallel. What about planes? Darn right they can. 2 planes are parallel if they never intersect. So there's only one pair of parallel planes on here. It's plane, ABC. So plane ABC is parallel to plane What else you got? D, E, F. Yep. All right, ready for a challenge, honors kids? Lines can be parallel. Planes can be parallel. But can a line be parallel to a plane? Yes, it can. Ready? Here's when a line and a plane are parallel. Remember the two planes we just had parallel? From ABC, name me a line. BC. Okay. So we could say that line BC is parallel to BC belonged to this plane right here, which was parallel to what other plane? Okay. So if two planes are parallel, any line from one plane is parallel to the plane on the other. Make sense? Whoa, you're not done. One doesn't make you great. Give me a line from the other plane right now. DEF. Give me a line. So we can also say that DF is parallel to which plane? ABC. So that is when a plane and a line can be parallel to each other. All good. No issues with parallel lines or planes. Perfect. Curl. You guys are awful. Awful. This is going to be a long year. Curl. Line segment. Now here we go. It is a part of a line. How do I know it's a line segment versus an actual line? Instead of arrows, you will have endpoints. Endpoints. Points. Remember how we name a point with a capital letter? That is a line segment. How do I write it mathematically? You guys have seen a bunch of these already today in class. Instead of having the arrows, I take them off and write the endpoints. So that I would read that line segment BC. Or do I have to go from left to right? Nope. If you're feeling crazy, you can go CB. You don't have to write this part down. I just want to show you something before we get to the next one. Could you come up and point to me line segment BD? Could you show me where line segment BD is on my diagram? It is this part right here, right? Line segment BD. What would you call this line segment right here? ED or DE, okay? What about the whole line segment? I could keep it BC or CB, but now I could go line segment BEDC if you wanted to, okay? 2 points minimum. All right, what can I do to all three of these mini ones to get to the whole one? I can add them up, all right? Dust off your algebra skills, everybody. Dust them off from the summer because you're going to need them. Draw. Talk to me now. Let's start talking geometry to each other. What's that say? Draw what? Line segment EG. Go ahead. Draw your own line segment EG. And this is just a draw, so it's a sketch. I'm not looking for greatness here. But your two endpoints should be what? E and G. And somewhere on there, we're going to put F. Doesn't matter where. Doesn't say in the middle. Just says somewhere on there, put a point F. Perfect. All right, let's keep talking. Notice now, it says if EG. Whoa! What did I just take away from that? I took the line segment symbol off. If you see that, the line segment symbol is gone, it's telling me the length. All right, so the length of EG is 100 units. All right, so when I take the line segment symbol off, that's how I write the length of it. All right, so I don't know how you want to denote that. That's totally your call. I sometimes like to go, whoop, that thing is 100 units long. EF is 4x minus 20. And FG is 2x plus 30. You got 3 jobs for me. Value of x, length, actual length of EF, and actual length of FG. 3 jobs for me right now. So I'm going to ask somebody, can you set anything up maybe for me to solve that would give me x first? Because that's where I got to start. I can't find EF or FG unless I find the value of x. So anything you can set up for me, that'll find x. 17, you're up. How long is the whole thing? 100. What's each piece? What's EF? What's FG? I put them together. How long is it? I put them together. How long is it? You were right. I'm just asking again. Okay, so can you write me that now? Put them together and they equal 100. Go ahead. What do you got for me? There you go. 4x minus 20 plus 2x plus 30 is equal to 100. I'm adding those 2 segments to get to the whole one. All right. And I'm going to go step. I know you guys could skip steps. I'm okay with that. I just want to know step by step, though, what do I do here? Just so your algebra skills are on point. 20, what's my first step here?
Add 4x minus 20 plus 2x plus 30.
Okay, go ahead. What do I end up getting when I combine like terms?
6x plus 10.
Thank you. Next step here. What do you got for me? 13. Yep, and this is where you honors kids start panicking. Oh boy, where's my calculator? Where's my calculator? Where is it? I need you. 3, next step. You do. And you're praying that I don't ask what it is, right? Hey, honors kids, I don't know if you've ever seen this before, so you don't need your calculator. Ready? 6 and the 9. How many times does 6 go into 9?
2, 1.
Oh my God. Just once, right? 6 and the 9 goes once. With how many left over? 6 to 9 goes in once with how many left over? 6 into 30. We're done. All right. Or just use your calculator. Bad news. I'm only going to give you a third of credit. Yeah, I'm going to give you partial credit on this one. We're not done. How many jobs do you have at the beginning? 3. You only did one of them. So now let's go and find what EF is. Suggestion on how I find the actual length of EF. I don't want the full, whatever I put up there, the 4x minus 20. I don't want that. I want the actual length, please. Don't pull that on me. Oh, suspenseful. Suspense. 17. On fire today, boss. How do I find, now that I know x is 15, how do I find the length of EF? Plug and chug, as I like to say. Substitute in. 4 times 15 minus 20 will give me 40. And then FG, a couple different ways you could do it. You could plug in 15 to 2x plus 30, or how long is the whole segment? 100. That part's 40. Other part's got to be 60. There it is. All right. Whew, everyone all right after those algebra skills? Whew. A lot of those on homework tonight in the book. If you can add them, good job, Flip. You can subtract them. All right. And oh boy, you thought that algebra problem was tough? Wait to this one. Draw. What am I asking you to draw? Line segment RS. Go ahead. Line segment RS. and put a point P somewhere on that segment. What's this telling you here? If RS equals 24, what's that telling you? The length of RS is 24. I'm really racking your brain on this one. RS is 24, RP is 10. What's the length of PS?
14.
Whew, really racking your brain, honors kids. All right. Oh boy, I'm gonna get somebody here. Somebody's nervous. Somebody's nervous. Who's it gonna be? 2.
14.
Nice job. 14. New kid bringing it strong. First one. Good job. I just wanted to show you guys you can subtract too. We added them on the previous example. You can subtract them. Final concept for today. Segments that are congruent. You ever heard of that word, congruent? Okay, they have this, they're the same length. They're the same length. 2 segments that are congruent have the same length. What I need you to do for the picture part is draw your own 2 segments that look like they have the same length. Put endpoints with letters on them, please. A, B, C, D, whichever you prefer. Whoa, whoa. Okay. I have no idea if they're the same length. I'm not going to eyeball it. Hopefully there's some type of units on there, right? That say they're equal in length. Okay. So you guys know that AB, line segment AB, and line segment CD are now congruent. I do not want to write the word congruent. I would like to use the symbol. Get used to this symbol because it will be used all year long. Anybody know the congruent symbol in the mathematical world? Yes. Isn't that the equal sign? Oh, so it also represents congruent. That's part of it. But you're missing something. That's part of it. Riley? Oh, God, that hurts my heart so much when kids say squiggly in math. Yes, oh, just stop. You're just embarrassing yourself. The similar symbol. That's what it is. You go ahead and you just put the squiggly on there. That is the symbol for congruent, ladies and gentlemen. Yes, that is the symbol for congruent. Symbol for congruent. Reminder, what class are we in? Honors, yeah. I can tell you, honors kids, it's rare that they'll put units on there. It's rare. So how in the world are we going to know, as we're reading a textbook for homework or a test or quiz, that those are congruent? Instead of putting the units on, we're going to put markings on them instead. The markings to represent 2 line segments that are congruent are hash marks. Hash marks. So you will see those. If you see those on any diagram, those 2 segments are congruent. They do not have to tell you how long they are. Whoa, not done yet. I got a challenge, follow-up question. Because you will have problems where there will be 2 sets of, just pretend these are, can you just pretend there? Oh, look at that. There you go, now they are. You're going to have problems where there's going to be 2 sets of congruent segments. But I can't put hash marks, 1 hash mark on all of them. Right? If I do this, okay, those 2 are congruent. I can't do that here because that would mean all 4, and obviously they're not. So how do you think I can show these 2 are congruent but not congruent to those? All right, what do you have? Sorry, name? Sorry. I had it. Maya. Yeah, be confident, Carlina.
You do multiple hash marks, and then there's third set.
Oh, can I? Yes, you put 2 on. All right, so you may see 2. Okay, that's how you distinguish which pairs are congruent. All right, one more, kids. And you can do this within your partners right now. Give you about 45 seconds. Which is following? Incorrect. Incorrect. I put markings on there for you. Which one is incorrect? Go ahead, talk it over with each other. Think we got them? Okay, let's go through each of them right now. All right, instead of just circling the right one, and that'll be it. AB, is a line segment AB congruent to line segment CD? Yes, I gave that to you. That's what those markings are. So that is correct. We're looking for the incorrect one. What's this saying? Is the length of AB equal to the length of CD? Yes. Why? Because they are congruent. That's the definition of being congruent. All right, now we get a little challenging here. Line segment AC, is that congruent to line segment BD? I see a lot of you saying yes. How? Where's the why behind it? Because I never marked them congruent. So how'd you get to that point, though? How'd you get to that point? Because you're right. It is true. You're right. It's true. I just want to know how you got to that point. Explain to me mathematically how you got there. That's what I'm trying to get you guys prepped for here. Maya, what's up? Okay, these two originally were congruent. Got it. Yep. Okay, I got you. Ready? Everyone, how do I go from AB to AC? What do I need to add to it? From AB to AC, what do I need to add? What line segment do I need to add on to it? Everyone agrees I got to add on BC, right? Okay, same question. What do I need to add on to CD to get to BD? So aren't you adding the same thing to two things that are already equal? So your result should be equal, right? Yep. And then the one that was not correct, AC, clearly not equal to CD. All right, AB and CD were equal. And now I'm getting bigger, so there's no way those two could be congruent. All good? Okay. You guys have two options. First of all, there's a typo. I don't want you guys to get confused. It says bottom of this page, page 11, but it's page 9 we're on right now. Okay, so yes, bottom of this page, and then you got the bookwork separate. All righty? Got your Chromebook? Why don't you get that out so we can sign up for some stuff? For 28 through 32, you do. Okay. Everything else is 7 through 9, 23 through 36, and then when you get to 28, you do 28, 30, 32. Okay? Yep. Go to Aspen for me. Left side, page directory. Honors geometry. Oh, already signed up. Good. All right, so go ahead, go to the page. Okay, so anything you need will be right here because I don't use Google Classroom. Okay, anything you need will be on Aspen. All right, so for instance, go ahead and click on the Unit 1 folder. If you need a copy of the packet I gave you, it's right there. Homework answers. You are I ask all these kids to make sure you check your homework answers before you come in.
Okay.
Okay, so if you open up, what's that? Yep. So if you open up the homework folder right now, go ahead and open up that homework answers folder. You just go to whatever week we're on and you find the correct day to check your answers. Okay. Do you have a textbook? Did you use an online textbook last year? Okay, so that login should still work. The only thing you're going to need is, go ahead, scroll down, the redemption code. See where it says online textbook instructions? Yep. So you're going to go back in, log on, follow these directions, and then there's the redemption code that you'll type in to get the, because you have the algebra, you have access to an algebra one probably. You just need access to a geometry one. Okay. Did you get one in lab school or no?
I don't know. I wasn't in for very long.
Okay, that's fine. So just make sure you can do the same login and password that you did last year. Okay, you just need to redeem a new book. Okay. Last thing, I post. Actually, that's a good idea. I should probably stop the video.